Na hii amenipatia hii kalamu. Bwana, I need another pen. Yes, we want to start our class. It's on linear programming. So we need to understand what linear programming is all about. Now, linear programming is a way of optimizing a linear function. So based on the some set of constraints. So we may be having a limitation or scarcity of resources like raw materials, like labor and so forth. So as an organization, we may wish to understand at what level are we able to achieve our objectives. Now, in linear programming, the objectives are usually two. The first objective is to maximize the gains, usually profits, and the other objective is to minimize the cost. So all this is achieved subject to the information that you've been given in the equation. And the informations are basically based on certain constraints which are not able to be, the firm cannot remove in the short run. Now, we want to see, basically, as I've said, in a linear programming, there is an objective that is to be achieved, and the objective may be profit maximization or cost minimization. We don't minimize cost, we don't maximize cost we minimize, but the profit we maximize. So the objective when it comes to profit is profit maximization, and when it comes to cost is cost minimization. Now, as I've said, there are two parts of linear programming. We have objective function and we have constraints sets. So it is upon you to identify the objective which the question is basically the question wants you to solve. So you have to understand within the question what is the objective. Is it profit? Is it profit, or is it profit maximization or cost minimization? Now, once you have formulated of course, you'll be asked most of the time that you formulate your linear function. So you come out with a set of the objective, then subject to the constraints, and then you also have to introduce non-negativity constraints, which is y is equal to more than 0, and x is also more or equal to more or equal to more than or equal to 0. So this non-negativity constraint in a linear programming is to ensure that you don't come up with 0 answers, so that you don't have you don't have a negative answers. I mean, so it's to ensure that you don't have negative answers, and that's why we are saying once you have formulated your function, you must automatically come up with a non-constant, non-negative constraints. The y is equal to or more than 0, x is equal to or more than 0. Now, there are two methods which are used to solve linear programming. The first one, which is common for your purposes, we have graphical method. The other one is a simplex method. So we are going to focus much on graphical method, on how to go about it. So using a graphical method, we have x-axis and y-axis. So once you have obtained whatever you have here, then we shall be able to see how we are able to solve our linear programming problem based on any of those. Now, just as we usually do, we shall look at a question first and see how we are able to go about solving a problem on linear programming. So this is November 2021, your paper, question 3A, and the whole of it is 12 marks. So we have 12 of it is 12 marks. So we want to look at it, November 2021, question 3A. So November 2021, question 3A, this is the question. Mjengo Limited manufactures two products, P and Q, using machines machine A and machines A, B, and C. Product P requires 2 minutes of machine A, 3 minutes of machine B, and 1 minute of machine C. Product Q requires 3 minutes of machine A, 2 minutes of machine B, and 1 minute of machine C. The capacity available per week for each of the machine is 1500, 1500 and 600 for A and B, A, B, C, A, B, and C respectively. Then the profit per unit of the product P and Q is 10 and 12 respectively. Then with those informations, you have been asked to first item, formulate a linear programming model from the information given above. Number 2, using the graphical method, determine the weekly production that maximizes profit. Now, from that alone, you are able to clearly see that the objective here is about profit maximization. And so, as I've said, you must have two parts. The first part is about the objective function, and which may be cost minimization or profit maximization. So we are there. The question is November 2021, question 3A, which I've already read. Mjengo is on Mjengo Limited. Yes, so the question is on Mjengo Limited. So you want to have a look at it together. Thereafter, we shall look at the other question. And after we are done with it, the work will be on you now to proceed and look at other papers touching on linear programming. Now, we are there. Now, the first objective, so we have the objective function. Objective function here is to do what? To maximize profit. So what are we maximizing? Maximize profit. So how do we start? How do we start? This pen is. So we start by saying, let product P be X, and let product Q be Y. Therefore, the objective is that, as we have said, maximize. For each unit of P, the profit is 10. So 10, maximize 10. Maximize 10x. Plus for each unit of Y, profit is 12. So maximize that. So this is the objective is to maximize this. And you know this automatically X is the product P and Q is the product Y in this case. So for every unit that of P, there is a profit of 10. And P is actually the X. And for each unit of Q, there's a profit of 12. So the objective for us here is for us to be able to maximize that profit, but subject to some constraints. So subject to what? We have constraints. So constraints are those scarce resources that basically will limit our ability to generate more profit out of our production. So we have said you can actually work somewhere else. You've been told this is product P and this is product Q. So you have been told product P requires 2 minutes of machine A. So 2 minutes of machine A. It requires 3 minutes of machine B, 3 minutes of machine B, and 1 minute of machine C. 1 minute of machine C. Then product Q requires 3 minutes of machine A. So this is 3 minutes of machine A. And 2 minutes of machine B. 2 minutes of machine B. And 1 minute of machine C. 1 minute of machine C. So it is easier for you to be able to summarize it this way. So you know P is the X here. So P requires that of A, that of B, that of C in terms of the minutes. So Q, which is the Y here, requires 3 minutes of A, 3 minutes of B, and 3 minutes of C. Now the next thing for you to ask how much minutes of machine A, machine B, and machine C do we have for purposes of achieving our objectives in the context of the production that we are going to achieve here. Now, you've been told the capacity available per week for each machine is 15,000, 1,500, 1,500, and 600 for A, B, and C respectively. So the profit per unit of that is that. Now, the capacity available per week for each machine is 15, and then 15 again for A, B, and C. So A, B, and C are machines. So what you are having here for A, it should be 2. This is remember this one was our X, and this one was our Y. So 2X plus 3Y should be not more than 1,500. So we have 2X plus 3Y is less than or equal to 1,500. That we are done with this, the first machine. The second machine, 3X plus 2Y. So 3X plus 2Y again should not be more than, should be less than or more or equal to 1,500. Then we have C plus, or that's X plus X, X plus X, X plus Y, X plus Y is less than or equal to 600. So that is the formulation. You have formulated your work there, and you've been told formulate a linear programming model from the information above. So once you have done this, then you automatically again bring in the non-negativity constraints. That is why y is more than, not y is more than or equal to 0, x is more than or equal to 0. So as I said, these non-negativity constraints are a must. They must be included, and they will ensure that you don't come up with negative answers. Now, with this formulation, now you can proceed and basically plot your graph for purposes of solving this equation graphically. So just work out this way. We have the y-axis, we have the x-axis as usual, and then you decide a scale for you. So the scale, of course, we have the x and the y. So the scale, you can see a scale which is comfortable for you. So we can have, let's say 100. I think let us see 100 there. So 100, 200, 300. Now that will be less. So let's work with 200. So 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600. So I think then we can have 1,800. Then you simply plot. So we can have, of course, this one is the machine A constraints. This is machine B constraints. This is machine C constraints. So there are constraints, and these are the two and negativity constraints. Now again, here you have the 200, the 400, the 600, going up to 1,600. So here you have 1,000, 1,200, 1,400, 1,600, 1,800. Now you pick the first thing, or we have 2x plus 3y is less than or equal to 1,500. So you assume it is an equality for purposes of determining what is x and y. So you can have x and you have y, and then you reason out. Suppose this is that, then if x is 0, what will be that? So when x is 0, what will be y should simply be 3 divided by that, and that gives you 50. 500. What about if y is 0? Then automatically this is 750. So you have your 2 points, which will then assist you. So you have 2 points, 0, 500, and we have 750, 0, for purposes of getting the line. Now, 0, 50, we have 0 is the x. So x and then 500, I mean 500 is somewhere there. Then we have 700, 0. So 700 is up there. So you are on a line somewhere there. Then you can join this with a straight line. And that line is where we have the 2x plus 3y is equal to 1500. Now, the regions above these lines are the more than regions, but the region below this is the less than. So the region below this is the wanted region. The upper region is actually unwanted. Now, we proceed to the next question. You do the same. Item 2, we have 3x plus y plus 2y. So 3x plus 2y is equal again to 1500. So if x is if x is 0, obviously y will be 750. If y is 0, then this other one will be 500. Again, you have your point 0, 750. Then we have 500, 0. Then you plot them again. 0, 750 is somewhere there. Then 500, 0 is somewhere there. 500, 0 is somewhere there. Then you join again these ones with a straight line. And this is the way we have 2x, no, it's 3x plus 2y is equal to 1500. So you have done with this, and you're also done with that. So the next thing is yx plus y is 600. You can also have that equation somewhere. So let's say this is the third one. X plus y is less than or equal to 600. Again, x and y. So if x is 0, automatically this is 600. And if this is 0, automatically this is 600. So again, the points you have is 0, 600. And this one is that's 0, 600, 0. So 0, 600 is there. And 600, 0 is somewhere there. Again, you join this. You can see, join that graphically. And this is where x plus y is equal to 600. Now, of course, you know, we also have a negativity constraint. It means y must be more than 0. So all these points, which are negative points, these are not needed. Then x must also be more than 0. So all these points are not needed. Besides, it is less than. So it means any points which are above this, these are not these are unwanted points. Any point which are above that, they are unwanted points. So your region, your feasible region, are basically the ones at the corner, and that's how you usually solve this this function. So the corner points will tell you this is A, or this is B, and this is C, and there's a D there. But you know, we cannot be producing at B simply because to produce at B means that we are producing 0, which is not possible. We cannot be able to maximize our profit when we are producing nothing. And therefore, at the origin, now, so we consider this point A, D, and we can say A, B, and C for purposes of analyzing and determining at what point are we going to maximize the profit. So the feasible regions usually falls at the corner points. So we use the corner points for purpose of evaluation. So we come here. So we shall be, the objective was to maximize the profit, which was 10x. So objective was 10x and plus 12y. So we want to see total here. So we have point A, and point A, we have 0, 500. So it's 0, 500. Point B, the corner points is what you are interested in. So this is around 300, 300. So this is 300, 300. Then the other one is 400, 0. 400, 0. So the first one, x is 0. So x times x 0 times 10 is 0. The other one, 500 times 12. That gives you 12. So 12 times that gives you around 6,000. 6,000. Just a minute. 60,000. So this is 60,000. So if you add the two, that is 60,000. Then the next is 300, 300. So 300 times that is 3,000. So 300 times 10, which because x is 10, that's 3,000. And 300 times 12, that is 36. 3,600. 3,600. So if you add the two, you are going to get 6,600. Then you go to the second one, 400 times 10, that is 4,000. And 0 times 12 is 0. So that gives you 4,000. Now, you are asking yourself, at what point should we be able to maximize the profit? You have evaluated it, and you have seen that the point where we have the highest is this one. Just a minute. This one was 500 times that. This is 6,000. This is 6. Not this is 6,000, not 60. This is 6,000. So where you have the highest is this point, 6,000, 6,600, and therefore you advise the farm to produce 300 units of A and B so as to maximize on the profit. Remember, the A, the X was the first product, which was P, and the other one was 300 cube. So advice, how do you advise the farm? Advice, the farm should produce 300 units of each product, so as to maximize on profit. Now, what you are seeing here is a straightforward. First thing you have to consider, what is the objective that the farm intends to achieve? And as I've said, the objective are twofold, either profit maximization or cost minimization. So once you have understand that, then you formulate your linear function the way you have done here. Then you come and actually present it in a graph, the way you have shown here graphically. Then you are able to evaluate those points. As I've said, usually once you've drawn your figures, the optimal points will always happen or occur at the corner points. And so those points are what you're evaluating. We are avoiding this point of original because at this point, it will mean that you are producing nothing. So you cannot be producing nothing, and therefore we are avoiding this, even though it's also a corner point. That's that. So that's how that problem is solved. You may also wish to proceed and look at the next question. And the first one was on profit maximization. The next one will be on cost minimization. And the next one is, I don't know which sitting is this, but we have the paper. The sitting is not very clear. But again, it is one of your papers. The equation will be shared with you. So it is 7B. So I want to believe that the first question is clear and you are able to grasp the concept, how easy it is, and how you are supposed to go about it. So what I'm saying in linear programming, the first is the identification of the objective function, objective that you wish to achieve, either profit maximization or cost minimization. Now, the second question is a company uses two types of components, S and T, to manufacture a product. The per unit cost of the components S and T are that and that respectively. A unit of a product requires 4 units of component S and 8 units of component T. The company intends to purchase at least 13 components. The current market demand for the product is at least 64 units. Formulate a linear programming problem from the above information. Using the graphical approach, determine the number of components of each type that should be purchased in order to minimize total cost. So remember, the only difference between what you have already seen under profit maximization and this that we intend to look at under cost minimization is that when it is cost minimization, you evaluate the same way, but only you check at where you have the least cost. So in that case, if this is a cost minimization problem, then you would have chosen production of 400 of P and none of Q, so as you are able to minimize the total cost based on the available resources. Now, we are now starting on the second question. And as I've said, at the end of the day, we should all be knowledgeable. We should all be in a position to answer any question on linear programming. Just have to be critical and analytical enough. Now, we have identified the objective, and objective here to minimize. And what are we minimizing? We know at the back of our mind is cost, and so we are minimizing cost, to minimize cost. So first thing, let S be X. S is a component that is used in the production of the product we are using. Then let T be Y. So with those, then you can proceed. And now these are two components which are used in the production of this product we are producing. So the objective will then be objective minimize. What are we minimizing? We know that for every X that is produced, the cost of it is 3,500. So we minimize 3,500 X plus 4,500 Y. How is that coming about? For every unit of Y that we for every component of Y that we are purchasing, the cost is 4,500. For every unit of X that we are purchasing, the cost is 3,500. So if we have the total number of components of each of the items that we purchased, we multiply by their respective costs, we are able to get the total cost that we incurred in purchasing those components in the production of the product that we are producing here. So what is important here is the concept. So once you understand the concept, then there can never be any question that will be challenging enough for you to be able to tackle. Now, in this case, we have identified our objective, and it is 3,500X plus 4,500Y. We are minimizing that, and we know it is cost minimization. But subject to what? What are there? What subject to what? What are those constraints? So we have a unit of a product requires points of that and that. A unit of a product requires 4 units of component S and 8 units of component T. The company unit intends to purchase at least 13 components. So remember a total of that. So remember, the first thing you've been told, X and Y. We do not know how many components we are going to purchase, but the company intends to purchase a maximum, at least. Intend to purchase at least means this or more. So more. So it is either equal to or more than 1,300. So that's the first thing. We intend to purchase not less than 1,300, which means 1,300 of the total combination of those units. So it could be none of it could be 3 of one and 10 of the other. It could be 6 of one and 7 of the other. Combined together, they should add up to 1,300. To 13, I mean. So the first thing, maximum at least, which means more than that. And then second thing, The company intends to purchase the current market demand for the product is at least 64 units. So this product that we use 2 items to produce, S and T, the demand is 64 units. So, but remember, we may produce less or more than that, the market demand. We may not be exactly according to the market demand, but we should. It's not possible for us to exceed what is demanded by the consumers, because the consumers dictate what eventually we are to sell to the market. So in this case, you have been told that for each unit of this product, we require 4S, and 4S here is that the S is the X, and we are intending to produce at least according to the market demand, which is 64. So the total of X should not be more than, so it should be less than, or should be less than or equal to 64 times 4. 64 times 4. So times 4, this is 16. That is 25. So 256. And Y should be less than or equal to, should be less than or equal to 64 times the other one, the 64 times 13, not 13, 64 times 8. So 64 times 8. Because each unit of so it requires each unit of Y, which is the S, requires that each unit of this product to produce require 8 units of component T. So we shall be having 64 times 8. That is 32, 48, 51. So this should be more than, should be not be less than, so equal to 512. So that's the maximum. We cannot have more than that. Now you proceed and get your equation. And again, X is more than or equal to 0. X is Y is more than or equal to 0. Now with those, you come here again. You analyze your work, and this is the graph. So again, the maximum here is we have 250. That so we can have 50. So let's see. This is 50. This is 100. This is 150. 200. 250. Can have 300. Again, this one is 50. This is 100. This is 150. This is 200. This is 250. This is 300. Then, as we saw with the other one, X plus Y is equal to 13. So when X is so X and Y, when X is 0, this one is 13, and when this is 0, this is 13. So 0, 13. So 0, 13 is somewhere there. So it's 0 to 13. 13 is somewhere there. And 13, 0 is somewhere there. So this one, so this is what we have. X plus Y is equal to 13. Then X should be less than 256. 256 less than or equal to. So that's now just a straight line. So 256 is somewhere there. And this is the line where X is equal to 256. And Y is less than, should be less than that. So which means less than that, which means that these are the unwanted. These are the unwanted region, because it should be not be more than that. Then Y again, 512. So that's actually on the other side, higher side. So let's just assume that we had 400 here. We had 600 here. So we proceed, and let's say it is 800 there. So assuming the scale continues that way. So we have X. X is less than, Y is more than, Y is less than 5. less than 512. So this 512, this y, this where y is equal to 512. Now, the next thing, we don't want this region. So you can see it's actually becoming a very funny, so we don't need this. This is a negativity. And at this juncture, this one again, you see, this one was more than, x and y should be more than that. So this is the unwanted region. So this is the unwanted region. That is the unwanted, because x should be more than, so should be more than that. Okay, so it means that should be more than that. It means this is the wanted region. Should be more than that. So it means down here, this is the unwanted region. So if you look at this again, and y should be, it is 5 less than, so let's see, should be less than this. So it means these are not, these are unwanted region. And x should be less than that. So again, you have your corners, you have this corner, you have that corner, you have that corner, you have also this corner and that corner based on this question. So this, you can say this is A, B, C, D, A, B, C, D, E. Now you have the object was x, 300 was 3500x plus 400,